Today, in our wireless world, communications is ever more important in our lives, and learning about these technologies is best achieved with a hands-on approach in the lab. There are so many topics to cover and so little lab time that efficient and easy-to-use equipment is essential.
I need a unit where the students can quickly and easily build experiments and get the understanding that they need.
Now, from Emona, the maker of the best university-level telecommunications teaching system used by leading universities all around the world, comes the Emona Telecoms Trainer 101.
The ETT 101 is a single-board trainer designed for college and technical high school level, with fully documented course material and capable of delivering an entire introductory telecommunications syllabus which covers from basic analog and digital topics up to and including introduction to advanced digital schemes. With everything included, all you need to add is a basic oscilloscope or PC-based instrument. How can so much be done with one unit? The ETT 101 contains a number of independent signal processing function blocks. These blocks correspond to blocks in a block diagram, as used by teachers in texts all over the world. It's the universal language of telecommunications. Let's take a close look at these easy-to-understand blocks. For example, here is an adder with two inputs, A and B, on the left, output on the right, variable gain for each input. Also, next to it a multiplier, two inputs, one output. Another block is the phase shifter with an input on the left, output on the right, and variable phase control. Master Signals has quadrature carriers, high-speed clock, sampling clock, bit clock, simple analog message. All of these signals are synchronized. Several of the blocks included replace the need for any other benchtop equipment such as function generators, etc. By patching together these blocks according to the block diagram, real systems can be built and signals at all points studied, measurements taken, and all parameters varied. Let's start with a simple amplitude modulation experiment. Here is the equation. Here's the block diagram. Adding the message, multiplying by the carrier, creates the AM signal. Now we patch together the experiment according to the block diagram. We take the low frequency message, put it into the adder. Let us add some variable DC to the signal via the adder. Now, using one of the channels on the scope, we'll look at the simple 2 kHz message signal. We'll now view the output of the adder using the other channel of the scope. The output of the adder is the simple message plus the variable DC. We can vary the DC, vary the gains at the adder. You can see the message with the varying DC component. Take the output from the adder, we'll connect it into a multiplier. The output of the multiplier can be viewed on the oscilloscope. We multiply the output of the adder with the carrier to produce the amplitude modulated signal. We're viewing the output. Change the time base. Now we can adjust the various levels of the input signals to have the appropriate modulation index that we may be interested in studying. There we have 100% modulation. Notice how you can easily see the carrier signal and the message at the same time. Let's now take a look at a BPSK experiment in the manual. Start with a sequence generator, clock from the master signals, multiplied by our carrier signals gives us a BPSK. This is a typical block diagram. On the following page we have the BPSK generation, demodulation, filtering, then level translation of the recovered signal gives us the restored digital signal for demodulation.
Let's now build the BPSK signal. Start by clocking the sequence generator. Just like in the textbook, the student gets an immediate understanding of the meaning of phase shift keying.
20 years of experience allows Emona to provide an optimum selection of functional blocks to give the ETT 101 the broadest capabilities of any single board trainer of its kind. The ETT 101 easily fits into existing coursework that uses block diagrams, and it's designed to be highly student resistant with all inputs and outputs protected. It's that easy. Like building blocks, the ETT 101 is a system that is easy to use and extremely versatile. We call it BSKT, which stands for Building Student Knowledge in Technology. Contact your local distributor or us directly via our website to purchase your units today and stock your lab with BSKT and take advantage of our generous educational pricing.